Now another thing we can do is we can add energy to the system by applying a force. If we apply this force at a certain point in each cycle, so we apply a force as a harmonic function here, F naught sine omega t, then we can be adding in as much energy each cycle as it's losing due to the damping. So eventually it will reach some equilibrium where the energy added is the same as the energy lost. Now this equation is very hard to solve. But if you were to solve it, the solution would have the form x is equal to a cos omega t plus phi, where a is equal to f naught on m omega squared minus omega naught squared plus b omega m squared, where this omega is the angular frequency that you are applying the force with. Now, resonance happens when the amplitude gets very large. There's a few ways we can make the amplitude very large. If we make omega the same as omega naught, so remember omega naught is equal to root k on m for the system, so it's like the natural frequency of the system, the frequency which the system would like to vibrate at. Well, if we make these two the same, then this whole thing's going to be 0 here, and this will be very small here, and so the amplitude is going to be very large. If we have a completely undamped case where b is 0, then this term here is 0, and if it's undamped and we apply this driving force at the correct frequency, we can get the amplitude to go off to infinity. Okay, in reality you're not going to be able to do that, but in theory you could. So resonance happens for small damping forces when omega is close to omega naught, the natural frequency of the system. So any system that vibrates, you can find the natural frequency of, and if you apply a driving force at that frequency, then you will end up with resonance.
Okay, what I have here is a series of pendulums. They're all connected along this bar at the top. In a minute, I'm going to drive these pendulums by swinging the large silver ball at the other end. Now, before I do that, I want you to use what you've learned about resonance to predict what's going to happen to these different coloured balls when I do that. Be as specific as you can in your prediction.